Hello, everyone. Thank you for joining us in this session, the last session of the conference. This is session J1, Data Analysis for Floodplain Management Decisions. We have three great presentations. Let me introduce our first speaker and presentation. The first one is Elevation Certificate Data, Unlocking Opportunities for More Informed Floodplain Management. Susanna Foe, CFM with Forerunner. Susanna is a co-founder of Forerunner, which is a software startup working with government agencies to leverage per property flood risk information to streamline planning, compliance, and outreach. The company has partnered with U.S. Communities of all sizes to mobilize data applications ranging from regulation enforcement to adaptation planning. Susanna is a certified floodplain manager based in the Bay Area with experience working with local government in research and community development capacities. She holds a master's degree in risk and resilience from Harvard University and a master's degree in architecture from MIT. So, remember, as she's giving her presentation, if you'd enter your questions for the speaker during the presentation, that'll be great. So with that, let's get started with Susanna's presentation.
Hello, I hope you are having a great conference experience. My presentation is titled Elevation Certificate Data, Unlocking Opportunities for More Informed Floodplain Management. I'm Susanna, one of the founders of a software company called Forerunner, and we build floodplain management software for governments. Our mission is to help communities prepare for the impacts of severe weather and adapt to future conditions. And we have the privilege of working with a bunch of communities, including Harris County, Texas, Monmouth County, New Jersey, and Jefferson Parish, Louisiana. As software providers, we are constantly trying to find ways to ease the workflow burdens of people like you. And when we were first starting out trying to sort of understand the needs of floodplain managers, we thought that the primary pain point we would encounter would be access to straightforward modeling. We quickly found out that many of our partners do have access to sophisticated flood models, but lack crucial building attribute information to understand the impacts of flooding. And when I say building attribute information, I'm talking about sort of property level data like lowest floor elevation that can sort of inform things like emergency management, long range planning, and resident outreach. This meant that for a lot of the communities that we spoke with and a lot of the communities that we work with, it's relatively difficult to answer seemingly simple questions because of this gap in information. Some examples of those questions are, in a given flooding scenario, which of the buildings in my community will be flooded at or above the lowest floor? How many buildings have been mitigated in my community? When did this mitigation occur? If I put into place a higher regulatory standard, how many of the homes in my community will be non-conforming? We've had a chance to get some pretty good insight into how communities across the country are filling gaps in data. We've also worked really hard to diversify options for doing so by building software features that address it. So for elevation data specifically, we've seen communities of all sizes using LiDAR and remote sensing to estimate measurements like first floor height. While it can be expensive to procure LiDAR data, it can pay off in dividends for those of you who have done so. That the data sets can often be sort of multi-purpose and used across departments. They tend to be a sort of gift that keeps on giving. Some of the communities that we've spoken with have used Google Street View to fill in some of their gaps in building attribute information. Google Street View can be used for identifying building materials or doing things like counting steps to get to crucial elevation information. Other communities, some of the larger communities, have deployed their sort of internal surveying teams to fill in the gaps in elevation information. This obviously can be very, very expensive, especially if your community doesn't already have an in-house surveying team. but can be very effective in creating a very robust data set. Increasingly, communities that we speak with and communities that we work with are interested in creatively using data that they have in their filing cabinets to fill in gaps in building attribute data. In particular, we've found that a lot of communities want to sort of extract and mobilize data from elevation certificates for use in a variety of applications. This is the one that I will focus on because it is a topic of my presentation, but also because it was especially exciting for us as a software company because it felt like a promising way to sort of apply our development skill set. For those of you who are not familiar with elevation certificates, I'll talk a little bit about their utility. ECs are pretty useful because they have a ton of property level elevation data in them. So specifically, Section C of the elevation certificate contains data like the top of bottom floor, lowest elevation of machinery. They're also typically pretty reliable because they're surveyor generated. I'll circle back to this point later. They're also sort of pretty ubiquitous. If you work for or with a government, you probably already have this data on hand. But while the information in ECs can be very helpful in sort of informing decision-making locally, it can be sometimes difficult to translate a bunch of documents in a filing cabinet into a structured data set that can be mobilized relatively quickly. We've seen a few ways that this is done. So a couple of examples are that Pinellas County in Florida built an elevation certificate collection and transcription app. And they have successfully deployed it throughout the county so that floodplain managers in each sort of municipality in the county are able to input elevation certificate information into their app. And the sort of county compiles it, which has a multitude of benefits. The first one being that it allows sort of some of that manual transcription work to be spread out across multiple people. So that it's not just a sort of administrative burden for one individual. The other thing is that because the county sort of aggregates all the data, they can kind of manage it and make sure that it's as flexible and as useful as possible for the individual municipalities in the county. Miami Beach, Florida created a adaptation calculator to gather elevation certificate information from residents. The portal is really great because it acts as both an education tool informing residents of sea level rise, but also as a data collection tool because it asks for residents to input some of the data from their elevation certificates into the app. To support communities without the technical resources to build something to collect data, we've built an EC data extraction pipeline as one of the core features of our product. It uses custom trained optical character recognition models to read elevation certificates going back to the 1980s. And so we automatically extract data from elevation certificates. We do things like geocode the data. So we take the address that is pulled from the elevation certificate and we use it to geocode the certificate itself. We also do things like datum conversions for communities who have ECs that go back to the 80s. We also run validation on the elevation certificate data that we extract. The intent of the feature is to enable communities to mobilize it for a multitude of aims as quickly and as painlessly as possible. Regardless of how the data is acquired, we've seen some pretty awesome uses for building attribute data. I'm going to list a few from our partner communities, and hopefully they're sort of wide-ranging enough to apply to you in your work. So the first one is that we've extracted data from thousands of elevation certificates in partnership with the City of New Orleans. The data is being used for a variety of super innovative projects. Some examples are using elevation certificate data to understand subsidence and repetitive loss. Understanding these things sort of helps them allocate resources more intelligently, will also help them strengthen grant applications. So sort of on the topic of subsidence, because the city has historic elevation certificates, some of which are able to sort of track elevations for an individual structure over time. They can use this to understand how the sort of ground elevation is changing throughout the community. The second one is sort of understanding impacts of future changes in policy or resource availability. So our partners in Pinellas County, Florida are using some of the elevation certificate data that they are gathering to understand the impacts of future changes in sort of things like freeboard and also sort of the impacts of future policy coming down the line, like Risk Rating 2.0. All of our communities are using the elevation certificate data that we pull from their ECs to enable sort of smarter and more informed outreach to residents and property owners. Because we are extracting the data and it's easily exportable, it means that the data can be sort of utilized to segment audiences so that messages can be a little bit more bespoke for outreach. All of our partners are using our software in tandem with the elevation certificate data that we extract for them to enable sort of easier and more streamlined compliance. So let's see if I can switch to an example of this. So this is one of our partner communities, and we are extracting the data from their elevation certificates, which is depicted here. You can see that it's in 29 and also 88. And layering on some intelligence onto it by comparing the data that we're extracting from the ECs to, for example, the base flood elevation and the design flood elevation to sort of flag potential compliance issues. So while elevation certificate data can be immensely useful in driving more intelligent floodplain management, there are also sort of several challenges that we've come across that I'd like to share here to gathering elevation certificate data and also to mobilizing it. So the first one is process documentation. I think collecting elevation certificates, extracting the data from them, it can be a relatively onerous task. And for communities with high staffing turnover, this can mean that the process shifts over time. So for those communities, documenting how elevation certificates are managed and how the data is structured can sort of be crucially important. The second one is technical capacity. So, obviously communities have different resources and also different staff availability. We've found that some communities that we work with have a huge GIS team. For those communities, pulling data from elevation certificates and leveraging them geospatially can be relatively simple. But if you work for a community that's a little bit more resource constrained, that can be a pretty heavy task, heavy burden. The third one is data availability. So we found that certain communities face challenges in accessing ECs, particularly elevation certificates that are a little bit older at scale. In some of these cases, we find that, perhaps a document management system changed maybe in the 90s, and, everything, before 1995 got lost. Documents can be stored off-site, and that can sort of present a challenge for communities who are trying to sort of aggregate all of their ECs. The last one is data accuracy. So we have heard from different communities that elevation certificates may or may not be accurate for certain points in time. So for example, some of our partner communities have stated that, after Superstorm Sandy, some of the elevation certificates that were generated might not have data that's as useful as ECs that were created previous to the storm or subsequent to some of the recovery efforts. So I'll talk about these last two and sort of what we've been doing to sort of create solutions around some of these challenges. The first one is the question of data quality or data accuracy. We are about to sort of launch a new feature that we're really excited about. It's EC error detection. Since we're extracting data from ECs, we're able to sort of use it to run a series of validation checks on incoming documents. For those of you who see a lot of ECs, you know they can be sort of tricky to look over. So our feature is going to offer a second set of eyes for review. We think this will be particularly useful for resource-constrained communities. The feature has sort of twofold benefits. The first one is obviously enabling compliance. For CRS communities with just a couple of chances to get their ECs right, this can be hugely impactful. It also has the benefit of creating a cleaner data set to work from for sort of long-range planning applications. Because we're sort of detecting errors as they come in, it allows the data set to be sort of calibrated, as ECs are being checked. If you've already extracted data from your elevation certificates, doing some of this cleaning work and implementing logic using a program like Excel to run queries is also totally doable. You can ask questions like, is my lowest adjacent grade higher than my highest adjacent grade? And use that as a sort of way to identify ECs that might have errors pretty easily. The second sort of challenge that I'd like to talk about is data availability. So in addition to being able to sort of find your existing data, maybe it's stored offsite or something like that, if you're interested in using information in ECs for planning, you probably want a full elevation data set. And the nature of EC data is that, it only exists for structures for which elevation certificates were created. Luckily, there's been some pretty exciting work done on this front. So the Hampton Roads Planning District Commission has done some really lovely research on using elevation certificates and random forest modeling to estimate lowest floor elevations. We also did a pilot with Pinellas County, Florida, where we developed a machine learning model or a series of machine learning models that can predict lowest floor elevations. And I'll talk a little bit about that here. So we combined several submodels to create two main models, which answered a couple of questions. The first one is, what is the LFE for the structure? So the regression model that answered that question returns a LFE estimate to the 10th of a foot. It also returned an uncertainty metric, which allowed us to sort of communicate that to our users. The second question was, is the LFE below the BFE? So this is a sort of binary classification question. Is the LFE below the BFE true or false? We found that some of the submodels, like the ones predicting the presence of flood venting and the one predicting building diagram, had a big impact on accuracy. We also found that outputting predictions that were able to succinctly communicate uncertainty made them more easily mobilizable. Being able to generate a data set like this can be hugely beneficial for your planning purposes. So for the community we ran the models in, our pilot indicated that there was likely significant value at risk. Statistics like this can be hugely useful in grant writing and in communicating urgency to stakeholders. We also found that using ECs can be uniquely advantageous. So using ECs allows you to sort of more easily predict lowest floor elevations while taking into account things like the presence of flood vents. This makes it easier to sort of mobilize EC data for NFIP decision making, for example. Since ECs are often sort of already in municipal filing cabinets, this methodology can be significantly more cost-effective and faster than other similar strategies. And lastly, because ECs are in the public domain, they sort of presented fewer privacy concerns than other strategies. So that's it for now. I hope this gave you some ideas about how to use EC data in your work. I'm happy to expound further on any of the points that I made in the discussion, and I look forward to talking to you about it. Thank you.
Okay, great presentation, Susanna. Thank you for the presentation. And it looks like we have several questions that have come in. And these are quite interesting, and looks like people see an application for for your software. So the first one, are you extracting building data only or BFEs as well? This person said, I did an analysis a few years ago showing that 80% of BFEs are wrong on certified documents such as ECs. Bottom line, don't trust BFEs unless the community has a clear process for checking them.
That's a great question. Thanks so much, Corey. So the answer is that we are extracting the BFEs from ECs as well. So we extract most of the fields on elevation certificates. I think I talked a little bit briefly in the presentation about one of our new features, EC error detection, and the sort of point that the question asker made about sort of the data on ECs potentially being inaccurate was a sort of main pain point that we were trying to address with that feature. And so what it does is it takes the data that we're extracting directly from elevation certificates and it compares it to known data. And for the most part, for most of our customers and our partners, that means taking the data that we pull from FEMA and sort of comparing the BFE that we're programmatically pooling to the BFE that is noted on the EC. And sort of where those two do not align, we sort of call that out as a potential issue because I think you're right that oftentimes mistakes will be made, especially in sort of larger communities where there are lots of people writing ECs.
Right. Yeah, I find that in our state there's a lot of corrections that need to get made.
Yeah.
Here's another one for a community that has increased standards. Can the software pick that up?
Yeah, that's a great question as well. The short of it is generally yes. I think it depends on what the standards are. And so sort of over time, we've built out the functionality to incorporate local things like sort of freeboard or other kind of local requirements. Currently, we're working on being able to sort of validate ECs for communities that sort of regulate their X500 shaded X zones. So generally, yes, depending on whether or not that's very complicated. It might be something that we have to sort of develop a way to do as a custom feature, but yeah. And so then what happens is that we will take all the data that we extract from elevation certificates and we'll validate it both against sort of the data from FEMA and then also any sort of local validation points that we put into place.
Okay, very good. Next one is, have you talked to FEMA about building, about building in the checker or similar tool? I guess they're talking about CheckRAS, I assume, into the next iteration of the standard EC form. Would love for the EC form to be smart and less difficult for professionals to get correct.
Yeah, that's a great question, and
that's difficult.
Yeah, it's a good prompt also because I think we have had some conversations with FEMA, both sort of HQ and regionally, but anybody who's in the audience who is at FEMA and who wants to chat about sort of how we might be able to work together, we'd love to have that conversation. I do think that we're doing many things that could potentially be useful for streamlining the EC workflows going forward for local communities.
Okay, very good. All right, here's a good one. Is the first step in this process to scan old ECs and save them as searchable PDFs? I'm guessing you have some kind of coding to help convert datums from older firms to current datum where differences exist.
Yeah, that's a great question. Apparently they're all great questions, so I'll probably stop saying that now. So the first step is to scan the elevation certificates. Typically we ingest PDFs, but in the sort of realm of possibility, they can be sort of other image formats and, or they can be image formats, I should say. So that's the first part. And yeah, I'm a little bit, oh, the searchable part that I wanted to address. They don't need to be scanned in as searchable PDFs because part of the sort of, a core part of the feature is that we use computer vision and optical character recognition in order to sort of pull the data from, be it sort of an image or a PDF. A lot of the sort of Newer ECs obviously are searchable PDFs, so that can really help just because they're very clear and they're often typed. But we can also read, for example, handwritten forms. And then I think the second part of that question was on datum conversion. Is that correct?
Datum.
Yep. Yeah. So yes, we do. So for that, regardless of what datum the EC is produced in, we'll do a conversion to the other datum. So if it's in NGVD 1929, we'll convert it to 88 and back and forth, because there are many use cases in which you want to sort of use a different datum in order to, for example, compare the data from the EC to a map that comes in. And we do that using the NOAA's VDatum API, which is obviously publicly available and is incredibly helpful.
Yeah, it is. It's very, very good. Nice tool. All right, so let's see. Here's a good one about pre-firm. Trends in pre-firm subdivisions may be able to identify potential structures that are above the BFE, even though they are pre-firm. Let's see, I guess this is more of a comment. So with that would, with risk rating 2.0, that would be out of the window though. So that's kind of a comment. So question, does the elevation certificate data validation work on all ECs, new forms, and previous forms, which are now expired?
Yeah. The long answer is a little bit complicated, but the sort of general answer is yes. So currently, I think the question asker is potentially asking about the EC error detection validation. And we are currently, as we roll it out, running it on ECs from 2015 onward. And I think what that person is alluding to potentially is sort of being able to bring in historic firm information in order to sort of compare the values on older ECs. That's something that we have on our roadmap, but haven't yet done. It should be sort of rolling out in the next few months, though. In general, the sort of EC extraction. In general, the EC extraction itself, we can extract data going back to the ECs that were produced in the 80s. So the extraction part can be done on all historic ECs, but the validation part we're currently doing on 2015 and onward.
Okay, sounds good. In the error assessments, is it looking for comparisons to LiDAR data? I have found some issues with ECs incorrectly establishing the highest adjacent grade or lowest adjacent grade in comparison to LiDAR on the BF or the BFE.
That's a great question, and something that I would love to investigate with that person. So we've spoken with some of our existing partners about bringing their LiDAR data into our software in order to do some of those comparisons. It's not something that we have done yet, though.
Okay. All right. Let's see. So what's the typical time frame for converting the EC data, say for 100 elevation certificates?
Yeah. So for that, so I guess it's a relatively laborious process to train computer vision models to read ECs over time, especially for some of the older elevation certificate versions. They can be a little bit tricky, but we've already sort of done that work. And so now at this point to extract data from 100 elevation certificates, that can happen in a matter of, hours, an hour.
Okay.
The sort of mitigating factor on that would be, whether or not someone with creative handwriting wrote the EC. In those circumstances, it can take a little bit longer.
Okay. All right. Here's one from a fellow that does a lot of elevation certificate training workshops. BFEs on ECs are way too often wrong, as they normally ignore. So it looks like he was commenting on somebody else's question there. Can the software figure out a historic BFE versus a current BFE? I guess that ties in with what you were saying before. You guys have that coding in there. So, okay. All are there CRS points available for any of the possible EC analysis? Are you familiar with any credits that CRS is granting right now?
Yeah, that's a great question. So if the question is sort of referring to the sort of pilot project that I was talking about at the very end of my presentation, I'm not exactly sure whether or not the CRS is awarding points for sort of data science projects that are looking to generate lowest floor elevations, for example. But in general, sort of, I think I alluded to, and we've spoken about both our EC extraction and some of the sort of mapping that we do on top of that EC extraction. And for that, our partner communities do get CRS credits for those. And so the sort of pertinent ones would be some of the 400 activities that pertain to mapping, because we pull the data from the ECs and geocode them and sort of layer them on top of additional mapping. CRS credits can be procured for those. The other thing that I didn't talk about at all in the presentation is that for many of our customers, we also create a white labeled website where we enable them to sort of put their elevation certificates online for the public. And that's something that you can also get CRS credits for. I think it's the 352C WEB credits. I know specifically which ones they are. Yeah, and then there are a few other things that our software can also get CRS credits for that I think I didn't allude to in the presentation, but I'm happy to chat about.
Okay. All right, sounds good. All right, well, thank you so much, Susanna. That was great and good information. Thank you.
Thank you so much.
All right, so our second presentation is Emerging Technologies, Web-Based Tools to Analyze Data and Drive Decision. Quentin Cummings from FEMA will be giving the presentation. Quentin is a floodplain management specialist, a certified floodplain manager, and chair of the Data Analytics and Systems Committee for the FEMA Floodplain Management Division. He has served numerous roles in FEMA disaster response and recovery operations throughout the country for the last 7 years. Quentin, and there's other things that he's done. I'll skip to the end here. Quentin is a graduate of the 2014 FEMA Emerging Leaders Program and a former FEMA Resilience Fellow. He has twice been awarded the FEMA Administrators Award, one for Exemplary Emergency Manager and another for innovation. Quentin is currently working towards a master's in geospatial information sciences at the University of Maryland. So Quentin, we'll roll with your presentation now.
Hello and welcome to the Data Analysis for Floodplain Management Decisions Conference Session Group. I am proud to present on the Emerging Technologies Web-Based Tools to Analyze Data and Drive Decisions. My name is Quentin Cummings, and I am a Floodplain Management Specialist at FEMA headquarters in Washington, D.C. I work within the Dissemination Outreach and Training branch of the Floodplain Management Division. Thank each of you for joining the session today, and I look forward to introducing you to our Community Engagement Prioritization Tool, also known as the SEP or SEP tool. As I'm sure many of you are aware, FEMA's list of geospatial tools is quickly growing. Shown here are just a selection of some of the more popular or well-known options available to the general public. Each tool is different from the others, though many can be used in combination with the others in order to help perform an analysis. As mentioned on the previous slide, we will be focusing this presentation on the very first option on that list, which is the Community Engagement Prioritization Tool. Floodplain management's program strategy for this tool is to improve floodplain management in communities with the greatest risk, opportunity to influence the built environment, and/or interest in better managing their flood risk. The origin of the SEP was to assist our state NFIP coordinators in prioritizing communities for outreach and engagement. Simply, with over 22,000 NFIP participating communities and very limited resources, prioritization based on risk, opportunity, and interest not only makes sense, but it's really needed. This tool helps to solve for that by providing a platform that pulls together data from various systems of record and other sources to compare apples to apples when we're looking at communities. I do want to be clear, however, that this tool is a decision support tool, and it is not prescriptive in nature. It should help a user to make informed decisions about community prioritization, but it's still only one part of a user's decision-making process. It's important to recognize that these different tools occupy different swim lanes. I've been asked by a number of people, which tool should I use then? Which is the best one? To which I reply, well, that depends what your goal or your question is that you're trying to answer. While the SEP tool allows users to add data on things like earthquakes, fires, tornadoes, etc., those are not really inherently the purpose of this tool. And if that's what you're looking at, kind of all hazards, then maybe something like the National Risk Index may be better for that sort of analysis. However, if you're interested in a flood specific question or analysis, even if it's flood after fire, but if it's flood specific, I would argue that this is the best FEMA application or tool for that purpose, as the SEP was built to focus on flooding issues and on those NFIP communities, both participating and non-participating. All other FEMA tools, to the best of my knowledge, focus on the county as the level of geographic scale. This tool is different in that we're focusing on the NFIP community. When we look at counties, there are approximately 3,100 county or county equivalent jurisdictions across the United States and territories. That may be good enough to answer your question. But again, if you're asking a floodplain management or a flood insurance related question, particularly if it relates to the ability of a government jurisdiction having land use authority in order to influence that geographic area, then you're most likely interested in the NFIP community scale and the ability of this tool to help you with that. With over 22,500 NFIP participating communities and another 6,000 non-participating, all data within the tool is aggregated to the NFIP community. There are a couple pieces of data that we use with the county, such as individual assistance, because that's how FEMA handles that data. But as a whole, most of the data is all aggregated to the NFIP community level. As I mentioned, we do put things into buckets, if you will, the strategic attributes and risk, opportunity, and interest. Risk is likely the easiest and most intuitive attribute for us to wrap our brains around. We naturally, inherently think about a risk when we're thinking about hazard mitigation. Things like, what's the history of flooding? What's the population impacted? How many claims have been paid out, etc. This tool goes beyond that, in that it's not just about risk, but engaging your community on a whole range of indicators. And so we also have things like opportunity. This might be a little bit harder to think about, but essentially what we're doing is we're looking at communities where there's a higher potential to turn over significant portions of the built environment, especially that located within the high-risk flood hazard areas, or to influence the local population to consider mitigation and or insurance. Sometimes this relates to the proximity of time and space to a flood disaster. Such opportunities like HMGP, whether those are available. This is one example. The last of the three strategic attributes is interest. So when we look at interest or need, think about whether or not a community has their hand up asking for attention or help. Are they wanting assistance? Are they applying to grants? Do they employ CFMs? Are they sending their staff to floodplain management and flood insurance training events? Is there communication between the community and their state NFIP coordinator? And what about the community to FEMA? These are some of the ways a community may show interest, and we could use those data as factors within the prioritization tool. This right here, what you see is most of the available indicators within the SEP. Due to text size and space limitations, some of the indicators were left off the slide. However, all indicators can be found within the additional information widget of the tool. Overwhelmingly, though, if you count this up, it is the vast majority in almost all of the indicators. You are encouraged to explore the tool and the indicators available. Additionally, we're looking for feedback. So after you get a chance to play with the tool, reach back to me and let's have a conversation about the available indicators. Do we have the right ones? Are there better indicators that we could be using that there's data sets for? Conversely, are there indicators you see in the tool that you don't use or you just don't find valuable? If something is not being used, we also want to know that so we can remove it in order to help the tool run smoother and faster, have a better experience for that end user. So what should we keep and what should we add and what should we remove? Now we'll go through some of the features on the SEP tool. Do note, due to time limitations, I won't be able to run through everything, as I have an hour and 47-minute long video that kind of does that. But we want to show off a couple things here and also point out that if you like what you see, come by the booth and I can virtually help you, but I also hold 2 1-hour open office hours sessions every week. Eastern time, it would be Tuesday morning and then Thursday afternoon, where I can help individuals out with the tool. All right, what you see highlighted here is the map-centric design of the tool. Note that the smaller rectangle widgets, that gives you the ability to augment and edit the layers shown, as well as you can look at additional data, you can add data, etc. And then as you toggle that map in and out, you change the scale. Those infographics that are now highlighted across the bottom plus the far left, those are dynamically connected to the extent of that map, meaning when you zoom in, that data is going to change so you can see what you're looking at. Then we go to really the heart and the soul of the tool lies here. So within the geoprocessing tool or application found on the top left of the dashboard, here you can select which geography you're interested in, be it a FEMA region, a state, or a territory. After that, you can either use a default pre-configured engagement option or create your own custom engagement criteria. We do highly, highly recommend and encourage users to create their own criteria that is most important to them for their locations for their type of engagement. So when you use a pre-configured option, you're using essentially a default that is just a general purpose way of looking at it, if you will. What you get more value out of is if, as an end user, you think about, why am I trying to engage with my audience? What is the purpose of that engagement? Okay, now let me look at the 49 available indicators and choose the 3 to 6 that I think are most important to that type of engagement. Then you can put that in the tool, and you can even weight them individually so that some indicators are worth more than other indicators when we do the mathematical calculation for you. So to refresh, the general workflow is to select your engagement area of interest, then select your engagement criteria, and then do the weighting. If you do the pre-configured option, the weighting is already taken care of for you, but you can always use that as a template and adjust the weighting if you so choose. On this slide, you get to see an example of what I'm talking about when you can use a pre-configured option versus criteria that maybe you find more suitable for your analysis. The left half of the slide represents a pre-configured option for a CAV. However, the right side is alternative criteria that a user shared with me that they preferred. Neither is right or wrong. The user determines which indicators are most important to their analysis for that engagement option. One important point that I would like to stress here: in choosing indicators, be cognizant of criteria which naturally favors larger communities, such as number of claims or number of policies, these raw numbers, if you will. In many cases, using ratios or percentages will significantly alter which communities are prioritized within the analysis. By using ratios, indices, et cetera, that you're allowing these smaller communities to show up in the prioritization matrix, as opposed to if you just use raw numbers, you're just going to naturally, because of the scales of the communities, have larger communities float to the top. So yeah, you get to see kind of the left side and the right side, the criteria being different. Again, neither is right or wrong. So in this example, I ran an analysis on FEMA Region 6 using the pre-configured option for flood mitigation assistance, also known as FMA. As you can see in the top right, 5 indicators were selected with varying weights. Number of repetitive loss structures receive 50% of the weighting in this analysis, just to show you kind of how we're doing this, right? So with that selection, you can then see that in FEMA Region 6, this tool prioritizes the city of Houston. Probably not a surprise. It's a very large city with a lot of repetitive loss as the number one priority to engage for FMA projects. Again, this tool is not a prescriptive tool and instead represents but one tool in your engagement toolbox. If your office only has so many communities that they can reach each month, or if you do it on a yearly basis, this tool gives you criteria that justifies why you should go visit some communities with your limited time, right? Because they have the metrics here. So it's important to recognize that we're not saying one community is better than the other or deserving than the other, but we have limited resources and we just have to make choices. And this gives you justifiable data behind why it is that you're making those choices. Okay, I would be careless if I did not go over just a couple of the limitations and disclaimers. All data is going to have limitations and disclaimers. So as I mentioned earlier, data is aggregated for the most part to the NFIP community level. Some indicators are aggregated to the county level, such as individual assistance metrics. That's how FEMA reports that data. Another one is that data is not live. I want to stress this. It's not live. DHS limits our ability to connect to live systems. So we do a manual pull of the data once a year and then update it within the tool. I honestly don't know a single other federal tool that updates even on a yearly basis. So I think that's very valid. And generally speaking, what we're seeing is that communities aren't jumping up and down from each other. Just the ones at the top are getting further away, if you will, from the rest. All right, in population data. So population data inside the SFHA, it's going to show blank for a couple of those communities throughout the United States, or more than a couple. Sorry, it's going to be any community that does not have a digital flood insurance rate map. So the majority of communities across the nation do have a DFIRM, but that's not necessarily the case for every FEMA region. I want to stress here, though, we're talking about 3 of the 49 indicators that would not work then for these areas. The other 46 indicators work, and they work great. Just the way that we do the overlays, and we just use population from the census blocks, and we look at the special flood hazard area with the national flood hazard layer. We can't do that if a place doesn't have the DFIRM. So there's 3 indicators that you see right there: estimated population in SFHA, estimated population growth in SFHA, and then the ratio of population in SFHA divided by the total area of population. You're not going to be able to use those, but you still have all those other 46 to be able to use. All right, let's go ahead and quickly go into the SEP tool demo. So very easy to find. You can go to the Google machine and put in FEMA SEP, and it will be the very first option that you see there. Also, a couple options down, you'll see that video that I mentioned. That's 1 hour and 47 minutes long. Click that first link and it gets you to the FEMA.gov webpage for the tool, and you can read about it. Select this link. It will take you over to the ArcGIS website that will have all the information that you need for this tool, including the office hours that I have right here that you can connect with me on Zoom every Tuesday and every Thursday to be able to have your questions answered. The top right has the ability to log in. Note that you do not need to log in. By logging in, you get a couple extra benefits from Esri that you can use the Living Atlas and other things to augment your map, but you don't actually have to if you don't want to. Then hit View Application. It'll open up, and then you've got yourself the tool. So you can zoom into different areas. You can, when you do that, you're going to see that the map automatically adjusts, and it's going to be dynamic with the data that you see down here that adjusts. You can also then select your regions, your states, and your territories, as well as pre-configured options, and then those 49 indicators that I mentioned. Ran just a couple options here for you already. And so you see this is FEMA Region 6. We used FMA funding, and you see that the darker the color, the higher the prioritization. Now the map, it's great to be able to visually see it on a map to see where it is in space, but you want to list probably, right? So that's where you come to the output and you just say you want to see that in the attribute table. Now you've got your list from Houston, Jefferson Parish, New Orleans, Harris County, et cetera, all the way down. Did the same thing when it comes here to FEMA Region 4 for a new map study, and you see the majority of it seems to be in and around Florida, Miami-Dade. You got some Panhandle up here, and it works your way up. But again, you can see the attribute table, and you can also export it to a CSV. So if you want to play around with it inside of Excel. So yeah, you've got lots of options there. Due to time, though, I'm limited and I need to end this. But please, if you have any questions, come see me, talk to me at the virtual booth, or log in to my open office hours on a weekly basis, and I will be happy to help you in any way I can. Thank you.
Hello, everyone. Great presentation, Quentin. I've had the opportunity to use this tool, and it's something that is drastic and very welcomed change from what we've had in the past. And the fact that you're updating the data annually is a huge difference versus the one we were using before that had a decade-old data in it. So it's very useful in a lot of different areas. And one of the questions I had is, are you seeing community assistance visits as the primary use for it, or are you finding other purposes for the tool now?
Great, thanks for that question, Corey. First, let me say that you mentioned the legacy tier 1 tool, and this is this tool, the SEP tool, actually replaces that. And you're right that fell out of use or fell out of maintenance about 10 years ago or so. And so we were happy to come out with a brand new tool using modern technology to be able to help our state partners and our FEMA regional partners to find various ways to engage communities. So as you just asked about whether the CAV is the primary use of the tool. Now, I will say that those that I've spoken to are primarily using this tool to find CAVs. However, I would like to encourage people to recognize that that is not the only use of this tool. In fact, we built the tool so that people can say of any engagement type they want, if it's related to floodplain management or flood insurance. So whether you're reaching out for grants, you're looking at communities to be able to do FMA, you want to know where the repetitive loss is in order to maybe take advantage of 90% federal funding, or something like this, or 100% federal funding for that severe repetitive loss. This tool helps our partners to reach out and engage communities regardless of the engagement type.
Okay. Are you, this is kind of a follow-up to that. Are you in the process of developing any additional training or guidance documents on the other uses for the tool?
Sure. So, I mentioned it in this presentation, but I do have a 1 hour, 47-minute long video that trains people on how to use the tool. And I go into some of this, but yeah, the same way that you can use it for the CAV, you can use it for any other engagement type. So there's not really additional training that's needed other than to know that you can use a pre-configured option. And there are a number of pre-configured options for people to choose, like HMGP funding or insurance education and outreach. So these are your pre-configured options. But really, if you have an engagement of any type and you just say, okay, what is the purpose behind me reaching out and finding communities to speak to? And then you select out of those 49 indicators, which ones are most applicable to that situation. And then you can run the tool. You can weight it as you see fit, run the tool. And then what I would highly recommend people do is then take that data and filter it down further. So once you have that data, you can export it, and you can export it into Excel, into GeoJSON, into a number of different file formats. And so know that this tool is not the beginning and end of your analysis, but is one part of your toolbox to help you figure out how to spend your limited time and resources.
Okay. Yeah, and I think that's a critical part, is you named the other tools that this is can be used in conjunction with. So, okay, very good. Is the data clearly labeled, whether it is countywide versus community level?
It is. So if you look in the additional data, it's going to reference that. So within the dashboard setting, there's a limited real estate, if you will, on your screen. And so someone would have to go into the additional data and see it. But for the most part, you're really talking about data that is collected at that level. And the big one to point out is individual assistance, for example. So FEMA as a whole, we put it up on Open FEMA. Data as a whole comes from, whether it's from Pivot for the flood insurance data, from CIS for the floodplain management data, Open FEMA for the IA data, for example. So if it's collected at the county level like IA is, it's going to be the same. Now, one improvement we are going to make as we update data next month will be that moving from the SVI, the Social Vulnerability Index. So as of current status, the SVI data is aggregated at the county level, but I will be transitioning that to aggregating it to the NFIP community level. So we are working on iteratively developing this tool to make it better and better over time.
Okay, very good. Can you download the data in Excel for all 49 data elements for a state, county, or region?
You can. Now, so just the format of the tool, you can only download about 1,000 communities at a time, right? And so if you're trying to download a state like Pennsylvania, which has more than 1,000 communities, that would be a little bit harder. But if most states have fewer than 1,000 communities, so you won't hit that limit. That said, just reach out to me. The data is live, it's public. We want people to have it. It has no PII at all involved. So if someone has any problems with downloading any of the data, please just reach out directly to me and I will set you up.
Okay, all right, very good. Next question, can communities use this to extract insurance claims and coverage data and other data sets they may not have?
So I want to stress with that question, and it's a good question, that there's no PII, right? And so depending on how they're asking the question, yes, communities can download flood insurance data for their community, but it's going to be, for example, number of claims in the community. You cannot download, throwing out an address, 201 Broad Street, and say how many flood insurance claims has 201 Broad Street had. So that's PII, and that's not going to be there. We just aggregate everything to the NFIP community level. So this way, there's no reason for DHS, FEMA, whoever else to kind of put limitations on us being able to provide this data publicly and available to anyone in the world. So that is something else I want to also stress, is that this tool is publicly available online. Just go to FEMA.gov and search, or Google and search for the FEMA CEPT. It'll be right there, and anyone in the world can use it. And we are actually hoping that academia and other stakeholders take a look at this data and help us along.
Okay, yeah, good suggestion. Is the number of mitigated properties based on what properties were mitigated via FEMA grants, or does it include mitigation done by other grants / property owners, etc.?
Sure, good question. So everything that's in the tool, there has to be a data set that we can find, right? And so right now, the tool only has data that FEMA is tracking for mitigated properties. And so if it's on a FEMA list, it's involved in this. So depending on how, again, their question would have to come down to, is that tracked, that it's mitigated and then sent to FEMA that it has been mitigated? Because if the answer is yes, and it's on our list, it's on Open FEMA, for example, then the answer is yes, it's in the tool. But if it's mitigated and we don't know about it, then it's not.
Okay, so it's basically the communities would have the responsibility of updating, somehow getting that information to FEMA to include it in the database. So, okay. So looks like somebody provided, Kate provided the link here, the URL for it. Time for one more question. The CEP tool only uses easy to obtain hard number data to make assessments. Is there a way for state coordinators to override the hard data based on the myriad of non-quantifiable locally based issues, in parentheses, state, local, funded mitigation, community, social issues? So I guess basically, is there a way to input something that the state coordinators can input data in somehow into the database that you,
Okay, so yeah, I just read it myself. So again, this is a situation where the tool provides the ability to prioritize communities based on the data that's in the tool. Right, so the data can only do, or the tool can only do with the data that's in the tool. Now, that said, as I want to, again, emphasize and encourage people to recognize that this tool can be used in conjunction with other tools and other data. So I've helped several state NFIP coordinators run some analysis within this tool, the CEPT, and then export that data and then put it into a GIS or put it into some other format where they performed additional analysis that I helped them out with. Okay. And I can do this with anyone on my open office hours every Tuesday morning, Thursday afternoon. I want to put a plug in for that. Those are also there. But so recognize that for the question, you can add additional factors. You can tailor your analysis based on your own criteria as much as you'd like. So the tool, again, it's going to be limited by the concept of how we built it, but your analysis does not have to maintain within the dashboard for all of the complete analysis.
Yeah. So again, I think you're just reiterating pretty much that it is one tool in the toolbox and a very good, powerful tool, but it should be used for additional data sources for depending on what you're trying to achieve with your information. So great job. Thank you, Quentin. Very good presentation. All right. Thank you for all the questions. All right, so on to our next presentation. This will be Christopher Moss, currently with Taylor Engineering, post-disaster rapid screening for likely substantial damage structures. Co-presenters are Charles Cook, and I don't believe they're going to be on this presentation and Benjamin Roberts. So they helped put together the presentation. Mr. Ross provides over 21 years of experience with more than a decade of project management experience focused on flood risk analysis, mapping, and hazard mitigation. He served as task order manager for the tropical storm Imelda and Hurricane Laura, substantial damage analysis and mapping task orders. He has overseen FEMA risk analysis studies throughout 10 states and FEMA regions 1, 2, 3, 4, and 6, including riverine and coastal surge analysis. Chris offers unique perspective on insight from working for a Texas municipality where he focused on the community's community rating system and cooperating technical partner programs. Including development and prioritization of the annual needs strategy submitted to FEMA for federal funding. So with that introduction, we'll let Chris take it away.
Good morning. I am Christopher Moss, and I thank you for your attendance today. Over the next 15 minutes or so, I will be presenting to you a method to screen for likely substantially damaged structures in the aftermath of a disaster. This method, as well as this presentation, was co-developed between the FEMA Region 6 Floodplain Insurance Branch Mitigation Division. First, what does it mean for a structure to be substantially damaged? A structure is deemed substantially damaged if, after a disaster, the cost of work for the repairs is in excess of 50% of the pre-disaster market value. With that definition out of the way, we can launch into the methods developed to leverage high water marks, specifically those from individual assistance inspections, to predict these likely substantially damaged homes. I'll outline how we obtain and then how we process this data. And then at the end, I'll give you an idea how we use this data in the aftermath of the disaster, in the coming months, and even in the coming years after a disaster. So why are we proposing to use the IA data, the high watermarks from the IA inspections? The SD process requires information about the affected structures and the flood inundation at those structures. Now, this data can come from a variety of sources. For instance, it could come from NFIP claims or USGS high watermarks. However, experience has shown that the data for these methods must be timely, should be comprehensive, it should be complete, and it needs to have successful predictive qualities. During the response to Hurricane Harvey in 2017, FEMA's Harvey Analytics Cell composed several predictive models. And what they found out is that in 80% of the cases, actually 85% of the cases, the IA data was able to successfully predict likely substantially damaged structures. Now that we have established an expedient and reliable data source, let's work on putting that into action following a disaster. After the disaster occurs, local community officials are responsible for determining substantially damaged structures. It's important to note FEMA does not make this determination. It is the local officials that do. So they're going to need some help. Here I'm presenting a typical workflow following a disaster. And what we'll do in the next few slides is work through this, and I'll show you how the process we have composed can be used during all of these steps. Once the disaster declaration has made, the region will work to put several data sharing tools into place. The first is called the routine use. And as I'm talking, you'll see some templates for these two tools pop up, and those are available from the region if requested. So routine use is defined by the Privacy Act as a use of a record for a purpose which is compatible with the purpose for which it was collected. This tool is not purposed to collect personally identifiable information from the homeowners, lessees, or occupants. The second tool they work to get in place as soon as possible is called the Information Sharing Access Agreement, or ISAA for short. This is a covenant between FEMA and non-FEMA parties and provides the terms and conditions of any information sharing. FEMA uses ISAAs to facilitate and memorialize the exchange and receipt of FEMA recovery data. The purpose of the ISAA is to enable FEMA to share PII, or the personally identifiable information that's protected by the Privacy Act. So we have our privacy agreements in place. We can start sharing data, but first we need to obtain this data. Who can obtain FIDA? FIDA is only available to the FEMA employees themselves. And there are two formats for which they are able to request this data. The first is a report format, which in the end looks a lot like an Excel worksheet. The second is a GeoFIDA format, which, as it entails, is an entirely GIS-based format. For the report format, the FEMA employee must both register and request through their internal systems. For the GeoFIDA format, FEMA employees must contact the Recovery Reports and Analytics Division of the Operations Branch GIS section. All right, we have presumably received our data in either report format or GeoFIDA format. Now I will give you a high-level description of how that data is processed, but I will emphasize the region does have an SOP that is a step-by-step guide for processing either the report or the GeoFIDA data. Both processes focus on a 1 and 2 story single-family residential homes high watermark cutoffs. There are 4 of these high watermark triggers that facilitate the filtering and the labeling of likely substantially damaged structures. For a single-family home, 1 story, that inundation level is 36 inches. For a 2-story single-family home, that moves to 54 inches. Mobile homes are tagged with 12 inches, and certainly any single-family home where the high water mark exceeds the first floor is also deemed likely substantially damaged. Now you might be wondering, where did these triggers come from? They are a result of years of inspection experience, as well as based on depth damage functions. These functions assume a standard stock with average depreciation, building stock that is. DDFs are compiled by an array of agencies, both here in the United States and internationally, and they're used to estimate the damage to a building, the percentage damage to a building, based on the inundation levels. They take into account things such as flooding conditions, of course, structure type, foundation type, and the number of stories. We presumably have received our data in either report format or GeoFIDA format. Now I will give you a high-level description of how we process this data. I will emphasize the region has an SOP available that leads the user step-by-step through either one of these processes. Both processes focus on residential structures, 1 and 2 story single-family homes, and both will leverage 4 key high watermark triggers that suggest the home may have been likely substantially damaged. The first is a single-family home, 1 story, and that flag is at 36 inches. When we move to 2 stories, that flag moves to 54 inches. Mobile homes are flagged at 1 foot of water or 12 inches. And any single-family residential home where the inundation level exceeds the first story is flagged as likely substantially damaged. Now you might be wondering, where do these flags come from? Well, it's a combination of years of inspection experience, as well as depth damage functions. These functions assume an average building stock with average depreciation. These DDFs are compiled by an array of agencies, both here in the United States as well as internationally, and they are used to estimate the damage to a building, the percent damage, based on inundation levels. They take such things into account as the building structure, foundation, cause of flooding, and number of stories. So we start with the FIDA worksheet, and through a series of steps, the data is processed and filtered and attributed based on that inundation level. And then what the end result from this worksheet is a list of structures that could be or suggest were likely substantially damaged. When this worksheet is complete, it is then imported into ArcGIS Pro, and through a series of spatial joins, such things are attached like the community, county, those kinds of things. And the end result is a list of structures by community that were likely substantially damaged, which can then be exported and provided to a community. The process for the GeoFIDA model is similar. The end result is similar, but it is an alternative to the worksheet, and it can facilitate the processing. It is a model composed in ArcGIS Pro by the Floodplain Management and Insurance Division of Region 6. Their GeoFIDA model is available for distribution. The model provides a very detailed workflow within the Esri Corporation's ArcGIS desktop application. Input to the model, besides the GeoFIDA file, of course, includes spatial files for the states, state outlines, counties, and community boundaries. The end result, again, is a spatially oriented list of structures which suggest were likely substantially damaged. So we've discussed what data is available. We've discussed why we're using this data, how to retrieve it, and given a high-level synopsis of how we process it. So now, let's talk about when and how we use that following disaster. So day 0, where we have or we're close to having insurance agreements in place. Roughly 2 weeks after that, we have requested our FIDA data. And then roughly 30 to 45 days following that, we have processed this data. And now we have a list of structures we believe were likely substantially damaged. So within 1 month, we have this list that we can provide to the communities to help focus resources, help focus inspections, and start that conversation, important conversations with the communities. But it doesn't stop there. We can use this data in the months and maybe years later for very transparent discussions during such things as community-assisted visits to help focus those conversations. So in reference to that, these long-term conversations, the region has developed a tool called the Community Profile. The Community Profile draws attention to metrics that estimate the individual structure's likelihood of being substantially damaged, SD. The Community Profiles include other program metrics such as the number of repetitive losses, obtain, maintain, uninsured structures. These additional metrics are correlated to the likely substantially damaged properties. The likely SD designation for these reports is based on historical claims across multiple FEMA programs, including the Individual Assistance Program, as well as the NFIP program. The designation is not a formal FEMA designation, but is useful for identifying homes in areas that may benefit from a focus on recovery and mitigation from past events. The profiles are intended to motivate mitigation planning efforts for specific neighborhoods within FEMA communities. And where applicable, the profiles do drill down to hotspots within communities where mitigation actions may prove particularly important. I would like to point out that the region does have a specific SOP for the development of these community profiles. What I have presented to you so far today has proven to be a valuable and timely tool to screen for likely substantially damaged structures in the aftermath of a disaster, as well as facilitate important discussions. However, this method does have some limitations, the first of which I will discuss are gap properties. This process leverages the IA inspection, specifically high watermarks. Now, FEMA cannot duplicate the assistance you receive from your personal insurance company. But you may receive assistance above and beyond those items not covered by your personal insurance. And some homeowners may forgo the IA process entirely and rely only on their personal insurance. In that case, of course, there would be no IA data. A second case where a property may not have IA data is where most inspections are completed within 30 days. However, that number may only be 80%. So depending on when you retrieve and process your data, there may be properties left out. These properties are what we call gap properties. This is why we emphasize to not solely rely or focus on a structural level, but to look more for areas or hotspots that this kind of damage may have occurred. The second limitation I'd like to discuss is that IA inspections only include residential properties. They do not include businesses, secondary homes, and most multi-family structures such as apartment buildings. And again, because we're using high watermarks, we are focused on flooding events. Those events where damage occurred maybe due to wind would not be captured by the IA data. There are other small events where a disaster declaration may not have occurred and therefore IA would not be available to the community and the residents. However, this process could be adjusted to use other high watermarks that might be available. And finally, the cutoffs that I have described for the high water marks are based on freshwater inundation. Now, there are DDFs available for saltwater intrusion or freshwater, saltwater with wave action. And those could be used, the high water marks could be adjusted for those environments. However, keep in mind that using the cutoffs we have described today is a conservative approach because those other environments would result in a higher level of damage. In summary, the methods described today are efficient, based on readily available high water mark data from IA inspections. The resulting data can focus resources in the immediate aftermath of a disaster, and this data can be used for communication for months to come, and it results in a very transparent, communicative environment between the regions and their communities. Thank you so much for your time and attention. I would like to thank the FMI branch for FEMA Region 6, especially Charlie Cook, who facilitated this entire discussion, helped facilitate the development of these methods, and did participate in developing this talk. Thank you.
Okay, very good. Good presentation, Chris. Thanks. That's useful information. We just had a disaster here in Alabama where we utilized that for Hurricane Sally, doing some analysis, post-disaster analysis from that, and I think we got some of our ways of approaching it based on what y'all did in Texas. So appreciate all the hard work you guys put into that. That's very good.
Terrific.
So we have some questions coming in, and let's go ahead and get those. Do you have different depth flags if there is a basement or crawl space? So I guess there's some way of designating something different if you have a different type of foundation.
So that was addressed by the region, and it's been their experience that if you have a basement or crawl space, there's usually insufficient information to make the determination. And therefore, those structures in this analysis are excluded. So you would need to, do more field work and take a look at those if they were out there.
Okay. All right. So can standard ISAAs, which is for the Privacy Act requirements, agreements, be in place prior to an event and renewed on a routine basis, or can they only be initiated on an event by event basis? My experience a few years ago is it was multi-month process.
So my understanding is that, yes, they can be put into place before the disaster. I will have to admit, I do not know on what sort of interval they are required to be renewed. I know if Quentin's still around, he might be able to answer that question, but yeah, I understand they can be put in place prior to.
Yes, and I can address that a little bit as a state coordinator myself. Annually, those need to be renewed, and you actually have one that's for ISAA for disaster data claims and everything that's you're talking about versus the regular NFIP data that's used, repetitive loss and NFIP insurance data, that sort of thing. So there's actually two different agreements. One is for your standard, which is the one being mentioned here, and then one that's used for disaster data claims.
Great.
Okay. All right, so next one is your average homeowner wants to rebuild immediately. This 30 to 90 day lag time for the data to come through could complicate timely permitting. Did the region address this, and what guidelines should the floodplain administrator provide to affected homeowners in the meantime?
I mean, that's just the timeline. If they're going to rely on the IA process, I mean, obviously there has to be time to get folks out in the field to do those inspections, and then a substantial damage inspection, is going to take a bit more time to line up after that. That's part of the reason why the region came up with this very streamlined approach to, take data that is already being collected out there, be able to process it and get resources out there and focused as quickly as possible. So really this whole thing was geared towards shortening that time frame as much as they possibly could. Prior to this, they had some very complicated models and such that kind of did the same thing, but they were much more complicated and needed much more data input. And so talking with them and about their experiences, our act was really to codify and bring together their experience and verify some of these cutoffs that they just intuitively felt were working for them, with some data, some of the depth damage functions, and it backed up what they were saying. So yeah, it's a process, and you have to do the inspections, and it's I want to reiterate, is the community who makes the official SD determination.
Right. And then that's one of the problems we ran into as well, Chris, was the communities, the citizens are ready to move back in as soon as possible. They want to get everything that they have to and just start rebuilding within a week. And unfortunately, that just doesn't work. And so it's up to the, and I think all states have put out a flood disaster recovery type of manuals on guidance for that, you basically have to put people off, even though it's uncomfortable and it's a difficult thing to do. It's something that just has to be done. So there's different ways to address it at the community level with building code, moratoriums on new permits and things like that.
Right.
Different things you can do to slow down the process. So the biggest thing is convincing your elected officials it needs to be done that way. So, but I'm sure you counter a little bit of that.
Absolutely.
All right, very good. So does flood water duration, in other words, how long the flood waters stay in a building, influence the likelihood of SD determination? Is that calculated in somehow?
So for this method, since we are looking at high water marks exclusively, assuming the high water marks are taken within a reasonable amount of time, you're not really going to capture, because that would be, you'd have a wicking type of effect up certain walls. So you might not capture that based on when the high water mark was taken. But intuitively, in talking to some building science guys, yes, that duration, can increase the damage. But I would have to say that generally, I don't believe that would necessarily influence the SD determination that much.
Okay. Yeah, I tend to agree with that. I don't think it'd be that significant. So.
Yeah, and I don't think that's a really truly black and white subject either, but I think generally it probably would not.
Right. Okay, well, very good. That's the end of our presentations. Thank you so much, Chris. Good presentation. Thank you to all the other presenters, Susanna and Quentin. Y'all did a great job. Great job fielding the questions as well. And if you have any additional follow-up questions, feel free. I'm sure they'll be glad to answer any emails that you have some questions to follow up on. And again, Quentin has office hours on Tuesdays and Thursdays that he's posted on the website for the CEPT. And so feel free to take advantage of that. And with that, I guess that's I hope you've enjoyed this session and the rest of the conference. We'll see you guys next year in Orlando. Thank you very much.
Thanks, Corey.